Hi guys, welcome. So in this video we're going to be doing electrical machines. So we have got two devices, A and B. So they want you to write down the name of the principal. So this is what we're going to do. So the name of the principal of this electrical machines, they call it magnetic induction. So as this coil turns around or through this magnets, it will induce an EMF. Depending on the position of the coil. So it will induce an EMF. So you'll have magnetic fields like this. Okay, magnetic induction. So they say write down the name of part X. So you see part X. You see the difference between these two. Look at this. This one separated. It has got a gap there. That gap, that's a gap there. You see, it's different from this one. This one it's fixed, and then this one there's a gap. The moment you see something with a gap like this one, this is called a commutator. It's a commutator. And then this one you'll have is the one that has brushes. Then obviously there will be brushes somewhere here, but they didn't show them. So this one, it's a slip ring. I'm just doing this for interest's sake. It's a slip ring. As you can see, how to remember that it's a slip ring. It's a complete ring. It's not splitted. It's a complete ring. It's not splitted. So that's how you easily can remember. It's a slip ring. It's a ring. A ring should be complicated. It should be not complicated. It should be complete. Rather, it should be complete. So you cannot say it's a ring if it's not complete. If it's splitted. So just say slip ring. You see, there's no gap. The one with a gap, it's a commutator. Okay. So 10.2, they say you are given 220 from a wall circuit to an electrical kettle with a resistance of. So you have V, which is 220, and then you have R, which is 40.33, and then they say socket provides RMS voltage. So meaning you have got IRMS and VRMS. So they told you that from a wall socket you'll have VRMS and IRMS. Then the first question says electrical energy consumed by the kettle per second. They want the electrical energy consumed by the kettle per second. Then they already told you that the 220 all the time, it will always be the VRMS. So you've got VRMS of 220, right? So they want you to calculate power. So when they say consumed energy is the power, average power. Always it's P average, the average power. So look at this. They want the power, right? So let's check. You've got R and VRMS. so it's 40.33 ohms. And then they want P average. Let's go to the formula sheet. So on the formula sheet, you look for the formula that has got P average. It's this one, you see. You check the one that has got everything that you're given, right? P average check that one. So obviously in this case they just want the P average. Okay, so when I say P average equals to, so the formula, right? VRMS squared over R equals to 220 squared divided by 40.33 equals to, so you just use the calculator there. Let's use the calculator. So you're gonna say 220 squared divided by 40.33 will be equals to 1201. So let's round it up to one decimal, obviously. So it will be 1000, then 099. You can write it like this, watts. That's your consumed energy. So the moment they say electrical energy consumed, then that's power. That's power. Then 10.2.2, they say maximum peak current. Maximum peak current. So they want I max. They want I max through a kettle. So they want I max. So let's check the formula. And then now we have got three values. Let me show you. So we've got P average, you've got VRMS, and then you've got R. So you've got P average, and then you've got VRMS 220 volts, and then you've got this one. So now let's go to the formula. Imax, where is Imax? Let's look for Imax. You can use any formula, guys, as long as you understand this. You can use this formula, any formula. So let's look at the formula that has got Imax. So you've got this one, right? Is there any other one? No. So it means in order for you to find the Imax, you have to find it through IRMS, which is equals to Imax over root 2. And then you're gonna make Imax the subject of the formula. So this is the formula that you should use. This is the only formula that you can use, root 2. So you see now, in order for you to find Imax, you've got another unknown, which is IRMS. So let's go to back to the formula sheet. So this is the formula that we want, the final one. We want Imax, but in order for us to get Imax, we need to get IRMS. So let's go and look. IRMS, where is IRMS? And then there's another one. IRMS, where is it? IRMS. You see this formula? IRMS, and where is the other one? Also this one. Then is there any other one? No. So you can use any of these two formulas. So if you check, you know VRMS, and then you also know R and P average. So you can use any of these two formulas. So I normally say use this one, any one, but please confirm your answer. So you can use P average equals to P average equals to VRMS times IRMS. VRMS times IRMS, or P average equals to IRMS squared times R. So you can use any of this, but look at this one. This one is a bit complicated because you need to remove the squared and all those things. It's a problem. So you know that it's 1200 099 equals to 220 IRMS. So IRMS, you make it the subject of the formula. It will be equals to 1200 0.99, okay, divided by 220. So IRMS will be equals to, just punch it on the calculator, just say divide by 220. That's 5.455. 5.455 amps, right? Amps, right? Don't leave it without units. Just write SI units. Just write amps. Then now you can go and substitute. You're gonna say therefore Imax equals to IRMS, which is 5.455 times the square root of 2. Then this will be equals to, I'm gonna just say times, just gonna bring the calculator there. Then you say 5.455 times the root of 2. Then we'll get 7.715. 7.715 amps. And that's how you do your Imax. That's how you do the Imax. Okay. And we'll do more questions on this. Please stay tuned. I'll do more sessions on electrical machines in the next session.